Today's program is Existing Masonry Evaluation Case Studies. Here's a program description and your learning objectives. Continuing education today, we have all kinds of ways to earn credit. We have 1 professional development hour, 1 AIA learning unit, health, safety, welfare, and 0.1 ICC continuing education credit. Certificates and evaluations will be emailed after the event. We do have a couple giveaways. Codemasters and pocket guides, really handy. Place your business card in the box and I will have that come around as we go through the program. If it will end up front somewhere, that'd be wonderful. Today's sponsor is Lambton Masonry, an experienced, professional, quality team performing excellence in masonry time after time. Brett Lambton has been in the bricklaying industry since 1984. Is Brett Lambton here by chance? No, but thank you, Lambton Masonry. And our co-sponsor is the St. Louis chapter of ICC AIA, St. Louis Building Code Committee. Thank you so much. And our speaker today is David Birenbaum, PE, Engineer of Inspection and Consulting Services. Mr. Birenbaum performs structural and forensic examinations. He's an expert witness and litigation support work is his forte. Dave performs evaluations of buildings for typical and atypical causes of movement and damage. He started his 6-person firm 24 years ago. He provides frequent training to the home inspector community and is often found at the Masonry Center training functions. Mr. Birenbaum is a Missouri Save Coalition, which is structural assessment and visual evaluation inspector. And he's trained FEMA disaster inspector for rapid visual evaluation of damaged buildings. He was deployed by FEMA as a structural assessment expert in the Florida Keys following Hurricane Irma and is packed to deploy for the next disaster as a SAVE team member or leader. He has earned his Master of Science in Engineering Management and Bachelor of Science in Civil Engineering, both from Missouri S&T. Dave enjoys outdoor adventures, canoeing, hiking, camping in the wilderness with family and friends. So please give him a warm welcome, David Birenbaum.
That's a fine how do you do. I'm losing it. There we go. Thank you, Margie. Good afternoon. Okay, I lost my clip. We'll just pretend I know what I'm doing here. Today's presentation, we're going to go over 13 different case studies of buildings I've been involved with evaluating. Work to my firm comes in various ways. A lot of times we get involved in real estate transactions from a buyer or a seller's perspective, but sometimes it's just people wanting to perform due diligence and become aware of things going on with their buildings, or they know something's going on and we get the call. Many cases, evidence of movement seems to continue either quickly or slowly, and people observe it happening. Sometimes we get damages assigned to us from insurance companies and other sources related to wind damage, tornado damage, hurricanes, earthquakes, those types of things. We do a lot of work with condominium HOAs, apartment owners, property managers, and quite often I get involved where there's a citation by some of the cities or the counties around here on things that aren't quite right, and owners are required to have an engineer's review of those situations. Can everybody hear me in the back? Okay, good. Typically when I get involved, I'm on site depending on the type of building, 2 to 5 hours is very common for a field evaluation. I initially listen to my clients' concerns. Don't want to throw those out the window, but quite often their concerns aren't necessarily related to what's going on, or their concern is on some aspect of it that's not really related to the movement itself. A lot of what we do requires tools, basic tools, tape measure, flashlight, ladder. In case of concrete movement, it's good to know where rebar is located or whether rebar is a portion of the problem. So I carry a Bosch Detect 150 rebar locator, infrared cameras, hygrometers, moisture meters. Some of our involvement requires doing dye testing to find out if we have, if we can detect water movement from point A to point B. We sometimes use chlorine strips to determine if we have potable water supply as a problem. Quite often, well, chlorine's only detectable for 1 to 2 days, and after that, the proper test would be a fluoride test. So we carry water sampling kits with us. We have one of the case studies today is going to be over mine subsidence. Portions of Missouri, including certain areas in South St. Louis City, have been undermined for clay and coal extraction years ago, and sometimes those cause problems that might be misdiagnosed as something else. I carry destructive testing equipment, and sometimes we have to rent a man to bring in taller ladders, lifts, swinging stage scaffolds, drone assistance, or to perform X-ray or petrography. If there's any questions, just feel free as we go along. Common causes for problem movement include poor workmanship or design, deferred maintenance, shifting of various kinds, and mine subsidence. The issues that are highlighted on the slide relate to slides that we're going to see in a bit. Less common causes for building movement include poor detailing, general slope failure, flood loads, surcharge loads, alterations of the structure in an undesirable fashion, tornado and wind, earthquakes, and other acts of man. We're going to see a few acts of man in the presentation today. Unfortunately, brick theft is common in parts of certain cities, and we have that going on here, but I'm not going to address that today. So when I'm included with what I'm doing to evaluate a building, we're trying to determine why something's going on. The next question, which we have to be prepared for always, is what should I do about it? Is it urgent or can it be delayed? So doing nothing is always one option. Some owners' intentions is to do things on the cheap or cover up. I get involved in expert witness work where lack of disclosure happens. So I'd say that's wrong every day. Delaying isn't necessarily a bad thing, though, in some cases. I also get involved in describing permanent repairs or design for those things. Sometimes it involves pulling off a portion of a building and replacing, and worst case would be raising the building if it's not safe or not justified to do a repair of a certain type. With this first case, we're looking at a typical subdivision house. This particular house is 20 years old, but they're still building them like this. We get a brick veneer across the front. With this particular house has some stone veneer on it as well. It does wrap around the left side of the house as you look at it. But note that there's no lintel creating the arch over the garage. It's just a wide arch with very little height to it. And note that there's just very, very narrow walls along the sides of the arch opening. From the street, you can't see what's going on. You look up closely. Yellow stripe indicates an inverted V-shaped crack that's developed because the arch is coming down. And if we look to the left and right side of this particular garage door opening, we have the walls are actually thrusting out. If you took a plumb bob, you can measure about 1.5 inches of out of plumb wall on the left side. On the right side, it was slightly less. And the yellow line on the left slide indicates the stair step separations through the brickwork. But that's not a good situation. So my recommendation for this particular case, the owner was hoping that my recommendation would be to tuck point. And going through this particular subdivision, there's a subdivision about 150 houses. Half of them were built similar to this. And I counted 12 or 13 that had open cracks like these or had already been patched, which isn't a permanent repair for the problem. The root problem here is that we have a building that was constructed without proper archways being considered. You don't get good arching action when it's really wide and you don't have a mass of masonry on each end to keep it from thrusting outward. So the recommendation is to remove the veneer above the place where it's become damaged about yay high off the ground. Fabricate a steel lintel to match the desired archway, and then replace the masonry by toothing it in on the left side and across the right side of the arch opening. So this is what was defined for the project. That's the design drawing. And here we have before and after pictures. The only difference is some of the detailed stones have been moved around, but it looks very similar to the original. They've got an almost invisible steel lintel performing its proper function. Case 2. Things people do have a negative impact quite often in my business. Sometimes it's stupidness. Sometimes it's just people not doing the right thing or thinking ahead. In this case, it was a matter of not planning ahead. We had an old commercial building on the right side of the screen with a very shallow crawl space underneath. New construction on the left side required excavating down 9 feet within a confined space within 5 or 6 feet of the adjacent building. So they dug it down, one rain, ground softened, collapsed the building. The good thing about brick is it has some natural arching action. Had there been further delay or if the arching action didn't occur, we'd have a collapsed roof system as well, and it probably would have been a complete teardown. But in the end, the building was repaired. The entire left wall of the white building has been replaced, as well as the foundation. Everything's nice. Insurance for the contractor on the left side, I presume, paid for that repair, but I don't know. Another case of lack of knowledge. Here we have a pleasant 3-story historic building built about 1895. Looks quite nice. Contractor comes in, finishes off the 3rd floor that hadn't been finished off in the past, sells it to my client. Client moves in. 3 weeks later, we had indication that where the yellow line is, the brick was hinging out and away because the rafters are just spreading apart. The contractor that finished this room, this room was disassembled for the repair, and we could see where nail holes were there for the collar ties that were taken off. So they removed the rigidity. The left wall of this building became flexible, and it moved outward. The right side was protected from that movement by just the style of the building. The chimney and the bump out on the other side provided a lot of rigidity. So there was no evidence of outward movement of that particular side of the building at all. The repair involved using aircraft cable with eye bolts and turnbuckles on each one, and pulling it back together and holding it in place. The hardware stayed in place, and we refinished the room space. Quite often I get involved in situations where the engineers ask what to do, give our advice, go away, and things go sour. And this is one of those. So keep in mind, I was involved with this building in 2010. The house is 4 walls of brick veneer on a poured concrete foundation. The foundation had moved inward 4 inches in the middle of this rear wall. I'm standing on top of a hill to take that photo of the house, so there's a steep hill towards the house. It's taking on a lot of moisture and a lot of pressure when that ground is saturated or frozen. And from the inside, the 2 photos on the right, you could see that the band board is no longer on the foundation at all. The foundation and the sill plate has moved inward 4 inches, such that the middle of that wall is no longer bearing on the foundation at all. And the rear wall and the roof are held up by the floor joists alone. So my recommendation was we need to, like it is so often with this kind of movement, is to excavate the outside of the foundation so that we can use, I like a dead man anchoring system where we pour a concrete strip in the backyard and put tie rods from the concrete strip to plates on the inside of the foundation, and use big nuts and big wrenches to turn simultaneously, and we could pull that wall back to a plumb position. The concrete block holds the wall permanently in place, and then we backfill with what I call a pressure release system, which is essentially a deep drain tile system, but the gravel is very particular, where we want to use river gravel, which is compressible, rather than crushed rock, which is not compressible, to keep the pressure from being applied to the wall. So what we're doing is reducing the pressure from something like 150,000 pounds against a wall of this length to maybe 75 to 80,000 pounds. Yes, sir.
So you said that you poured kind of like a grade that faced the wall with tie rods. Can you explain that?
Correct. So how many engineers do we have in the room? A few. So engineers use ranking theory to calculate loads on a vertical surface like a foundation wall. So what I would do is calculate the load of the soil against the wall after we dry it and keep it dry, and then we have to pour a concrete block, or it could be several concrete blocks, which is one method, or it's just as easy to pour a concrete strip, but we pour a concrete strip below grade, about 2 feet deep. Typically, they're around 3 feet by 3 feet by the length of the wall. And that concrete mass weighs at least 1 pound more than the horizontal force against the wall. Usually, the good engineers are going to add some percentage for safety factor. But we poured into that concrete would be a steel. I use steel C channels with a 1-inch threaded rod going back into the house, and then we use a 12 by 12 plate or a larger steel plate or steel C channels, depending on how broken up the concrete is. So the top of the strip is typically 2 feet below grade. It's a dirty job and tears up yards. I've never seen one fail. A different opportunity is to do the same thing with the pressure release system, but instead use helical anchors, how it spun out into the yard. That's less invasive. I've seen those fail, so I'm not a real fan of them. But there's reasons things fail, and there's a reason things can be made to work, but should be designed. So in this case, the year after I was first there in 2011, the owner chose to ignore my recommendation. They did have a helical tieback system put in. A single helical tieback is shown at the top right of that screen. That plate is like yay big, and the helix at the end is 8-inch diameter typically. The contractors typically core an 8-inch diameter hole in the foundation and spin it in from the inside and tighten it down. If this is an 8-foot wall, we want to be at least 8 foot away, probably 10 or 12 feet away for this to hopefully work. I've seen a lot of failures of these, mainly where nobody did anything to eliminate the pressure against it. And that's what happened here. You can see the stains below those metal plates accumulated from water getting through the core, and the wall continued to move. It took a while, but my client called me back this year, and we had failure of the brick because the wall was never pulled back. So the brick was just overhanging the foundation and it decided to give way.
They were trying to hold it.
It's called stabilizing it in place without regard to the overhang of the brick. In this case, it's you can maybe justify that repair if you have an overhang of 1 to 1.5 inches from the foundation, because it's still, the brick veneer is still bearing on the foundation. But in this case, if you look at the picture on the right, the blue arrow, that's the underside of the brick that was remaining. This is completely off the foundation. So again, my repair recommendation this year was the same as the first time, but now it's more costly because we have to undo what's there and start over. Particular foundation repair contractor had a lifetime of structure warranty, and they chose to put in more of the same. So that was the resolution. Case number 5, we have a very nice stately mansion down in the city. What we're going to do is pay attention to we're going to look at the detail along this side and the roof edge there at the back. This house was suffering from curdling paint, bubbling paint, and plaster falling off the walls. They couldn't understand why, because when you look up from the ground, everything. But when you get on the roof, or if you were on a ladder and look down, you'd see this strange layout of this wall, which looks original to me. I don't, if buildings could talk, we'd know more. But the top of the wall stepped back about 5 inches back to the roof line so that they could put a gutter on it. That left an open ledge for ice and water to sit. And you just look right in here. There's gaps that can never be tuck pointed. The water's just rolling in every time it rains from that direction. And then as a bonus, the last time they had the roof done, they took the coping tiles off, threw them away probably, or resold them, put a roof on. That's a modified bitumen roof. Bent at 90 degrees, which you're not supposed to do with modified bitumen membranes, and they used roofing nails to nail it to the brickwork. Don't know whatever happened. Made my recommendations to correct it, and sometimes we don't know what happened after. Here we have a nice historic church. The church was called by somebody who noticed that there was stone and concrete chunks falling from the belfry. We presumed it was from the belfry. There's nothing else there where we could see it coming from. But if you look at this photo, you can't see where that chunk came from. Everybody was straining to look and see. Before I came along, the owner of the church decided their resolution was going to put caution tape out there. So the caution tape remained for a long, long time, but this is the main entrance to the church. Nobody found that acceptable. The elders of the church decided to hire, well, they didn't hire anybody initially. They talked to 3 contractors, got 3 different opinions. The opinions were, contractor 1 says, let's replace the entire bell tower. Contractor 2 proposes pointing the entire building. Contractor 3 proposes pointing and sealing the brickwork and stonework, and then piering the entire foundation, telling them it was dancing around. They did talk to an AE firm, which proposed performing a $25,000 study, which might be money well spent, but it didn't seem deserved for the damage that was there that I was observing. So they didn't like any of those multiple solutions that they didn't pay for. I got the call, and no one inspected the bell tower prior to my visit. So the first thing I do is walk around the building, and the answer is right in front of us here, but you can't see it. These are telephoto views, and I'll just point to the problem that we're going to zoom in on. Problem is one of those columns on the far side of the belfry, right there. And I didn't notice it when I took this photo, but when I reviewed it later, it's like, oh, there it is. So when we get up to the belfry and look over the top, fortunately, this belfry had some stairs going up to it. A lot of times we don't get that pleasure of climbing from the inside. We have to get a lift to get up on top. But here you can just see the deferred maintenance. All the caulk joints have been opened up and water's pouring in for years into the structure at the top. And when we're standing next to the bell, we can see what happened. Is one of the columns spalled. The spalling was caused because they used steel or iron pins to retain the columns in place. The steel rusted, rust expands, and it just popped the stone off the side, and that's what fell down to the sidewalk. So when you look up from the outside, you see the face of the stone column that looks great, but it wasn't until I looked in the belfry that you could see where it came from. So the repair was actually pretty simple. It was a matter of getting a qualified mason up there to replace that one stone column using stainless steel pins. That was done fairly rapidly. End of story. Yes, sir. Well, I didn't show the other part. The other part of the equation is there's a concrete roof over the belfry, and it's falling apart because of bad roofing on the top, water soaking into the concrete deck. It's cracking up. Right now it's repairable, but as most small churches are, there's not money to make repairs. But the source is probably the old roofing, letting water in as well as water soaking into the stonework, plus just water blowing against it. This is an interesting case of a surcharge load. This is a large manufacturing facility. This is fracking material. So they have these large bags of fracking materials ready to go out on trucks and railroad cars. For a long time, they stacked them up in the middle, pretty much like it looks in the right photo. And then they decided to bring the mixing of, there's 3 different compounds that they mixed to develop this fracking stuff. And they put the equipment in the middle where these bags are and moved all the finished product out to the side walls. Now keep in mind that this was a building built around the Depression. There were railroad sidings coming up to each side, so the floor of the building is up at the height of a railroad car floor, so they could directly forklift into the rail cars. So now this production facility has all these bags moved to the outer walls, no harm done, except that's the problem. 3,500-pound sacks stacked 2 and 3 high is quite the load. And what occurred was the brick wall tilted outward 4.5 inches, and the windows, the old steel frames went with the brickwork, and it's ready to collapse. The good thing about this is if it did collapse, it's only the infill wall that would collapse. The steel columns that you're seeing there in the right photo actually hold the roof up, so the building would not collapse in this case. But 4.5 inches in a wall like this is pretty incredible. The repair was extensive. Client didn't want to make the repair, so to my knowledge, nothing has been done except they moved the stacks of stuff away from the walls. And can't argue with that. That's their decision, what they did. This happens from time to time. We get tornadoes coming through St. Louis, and this one came through on April 15th this year. We have a building constructed in 2003, concrete block, inner wall faced with brick in most of the exterior. You can see the aftermath of the tornado lifted the roof and lifted the top block course along the front of the building. What we can't see is on the inside, it also lifted the bar joists that are bearing on the side wall. Here's a close-up picture of the front from the roof line and then from the inside. This is the side wall where it lifted individual, the force of the tornado lifted the bar joists up, as well as the concrete blocks at the bearing points and next to those bar joists. That happened over bar joist number 1, 2, 3, 4, 5, and here in the picture we have number 3, 4, 5. And when we look closely at the bearing point, most of the bar joists are bearing on a piece of concrete masonry. In this case, somebody decided to use a chunk of brick. And looking closer from the lift I was on, that brick had not moved. It was just built that way out of not plumb, not flat, and there's no connection whatsoever of any of the bar joists into the masonry walls, which was a real shame. I'm just surprised in 2003 that wasn't required. Maybe it was an oversight, I don't know. The building owner had no plans. So my recommendation was remove all this concrete block and remove the top 16 inches of brick on this side where the 5-foot bar joist moved, replace it with vertically reinforced concrete block and bond beams at the top of the walls, and then reface the brick. But the owner chose this repair, which was tuck pointing. And they took the roof detail off the front and the side, and they they patched in a piece of TPO membrane and just wrapped it over the top and glued it to the masonry wall. So that's an accident waiting to happen. Even with TPO roofs are a fine product, they just don't adhere to brick very long. Couple 3 years might be all you get, and that adhesive will come loose from the masonry. So it's not a masonry issue, it's not a roof issue, it's a roofer issue. And it's a shame that I'm presuming that the owner had insurance and that they were paid for the correct repair, that they just have to follow that back. This is a mine subsidence case. In St. Louis, a lot of Dogtown was undermined, and a lot of the area south of Tower Grove Park from ours. Do we have anybody from out of town? So, just want to make sure talking to people that understand the city. So South Tarver Park from Arsenal down to Gravois, from Kings Highway to Gravois is one of the largest areas that's been undermined in the St. Louis area. And there's a lot of mind maps available. I carry one in my car. There's one available on the Department of Natural Resources website. In my line of business, it's good knowing that there are where mines are known to exist, because that does influence decisions on how to make repairs. So in this case, when I first walked up to the building, it looked like a case of, on this bungalow, of the front left and front right brick column settling down. Because as it settled down, I would expect that this added a diamond it's a large washer, but it's a cast washer with a 3/4 inch diameter steel rod that's run 10 feet back to tie into the foundation for under the living area of the house. So somehow that's supposed to keep horizontal movement from happening. Well, as is obvious, it didn't stop it from happening. It just, the brick pulled through around that connector. So in other cases, I would say shallow ground settlement might cause this type of problem. But then when we walk along the side of the building, using one's eyeballs, you can, this is looking, the right photo is from the rear towards the front, the other one's from the front to the rear. You just cite the joints in the brickwork. We can see there's at least 2 courses of brick difference in elevation from front to rear. Being like I am, I also carry a surveyor's level with me, so I shoot elevations within the house. We presume that the house is built level to begin with. So I shoot elevations either from the underside of the first floor or of the first floor itself to determine how much of has the building moved, what's the magnitude of the movement, where's the movement, so we know what we might be able to do here. In this case, it was 7 inches from the rear. 7 inches doesn't happen from shallow ground settlement, from the sun beating down on the soil. There's something else that happens. And bottom right portion of this screen shows the area of the city of St. Louis where this house is located. And it's really close to these mines here. And this mind map that's available, I was told it was done as a master's thesis back in the 80s for some student in engineering field. So generally the lines outline the area that's known to have mines, but mines also are outside those areas. There might be individual mine shafts going beyond those squares, rectangles. And if you look at the round circles, number 46, number 47, those are known shafts, but whoever created this map did not have the detailed map that shows where the area surrounding it that's becoming mined. So I concluded that in this case, with less than 2.5 inches of settlement, we might conclude that maybe mine subsidence is not an issue. But with 7 inches of movement, I'd say certainly it's either mine subsidence, or in some cases we could say that there's a conical feature, a sinkhole that was filled and maybe continuing to sink that might be causing the problem. So both Missouri and Illinois DNR have mine maps available online, and there's detailed mine maps that supplement this larger area map, so you can get really down to the individual lot level in some cases to find out where mines are located. An issue with the repair of mine subsidence is we would like to not have the mine there, but it is. Missouri has an office for mine reclamation. It's the abandoned minerals section of DNR. And if you call that office, you will find that there is a very large pot of money that they're willing to spend and want to spend on filling, eradicating these voids. So it was set up for extraction of metals out west near Joplin, where there's a lot of mine subsidence problems. But they're also using it in St. Louis now. When I run across mines and other engineers run across mines, they rapidly come out. The 2 times I've been involved with them, they come out within 2 or 3 days with a drilling rig. And they're out there drilling and trying to fill these mines to stop mine subsidence in that particular area. So part 1 of repair is let's try to fill the mine so we don't have further mine subsidence. If we can't fill the mine or can't find that there is a mine there, we just presume it's there. And most of these mines are 30 to 50 feet deep. So if the repair involves stabilizing the building by underpinning it with piers, those piers need to be deeper than the mine. They need to be 30 to 50 feet deep. So most of the piering contractors in St. Louis can push or turn their helical piers down to about 20 or 25 feet. It's common, and that's adequate to get the bearing pressure needed to support most structures. But in this case, they have to go down below the bottom of the mine to be successful, or they're wasting the building owner's money. So that was the bad news on this building is, yes, there's a mine. The Department of Natural Resources has not yet come out to fill the mine, and that's the expectation. Yes, sir.
If it's a typical city block for row houses, what, 30 or 40 foot wide, this all the way down the block or across the street, or
I don't know.
you didn't?
No,
It's just a question.
it's always a question on my mind. If there's can I talk about individual locations? There's a street known as Olethe in St. Louis. Yeah, I was involved with 6 in a row there. So the expectation should be if it's affecting one house, that same mine is probably affecting others, but it's seldom that I get involved for multiples of houses. And most people, if we're talking about a house, most people can't afford the cost, drive piers down 50 feet and bring the entire house. It would be $100,000, $150,000 job. It doesn't make economic sense on these average size houses. And that's the bad news I leave with. So I get involved with things where the question is, can we save this building? So this is a case where the owners love the house. It's kind of a cool front there with a T-shaped archway over the front entrance. The back is something to behold. The owner had gone through the process over a couple of years, hiring people to rip out all the plaster work and prepare it for a gut rehab. And then he hired an engineer to determine what's going on. Because his intention was to have this rear wall tuck pointed. But when we look closely at the brickwork, it's kind of funky on that left side. And you see the wiggle in the wall. As you look up the wall, it looks like it's out of plane at least 4 inches, maybe 5 inches up the wall. And then when we look on the right side, anybody see anything besides dumpy? It's just way out of whack. You can tell there's new brick infill there, so something transpired. Did it collapse and get rebuilt? That's possible. Was it just bad brick? Did they add windows that weren't there before? Don't know. But the old retained brick is certainly way out of whack. Look at this line. That's not an optimal solution. That's really what it looks like. And when we look perpendicular at the same corner, very generous slope. It's a pliable wall. Brick is very pliable like So in my mind, I don't think this person should be rehabbing this building until he resolves these big brick out of plumb issues. So my suggestion is to take down the walls that are grossly out of plumb and rebuild them. The back foundation wall is decrepit from years of deterioration and neglect, so a portion of the foundation needs to be rebuilt as well. The person's in the decision-making process at this point. I don't know what's going to happen. Now, this is an interesting case because this was a question of, can we save this building? This is a small historic building on a school campus built in 1840. It currently serves no purpose other than the basement of this particular building happens to house the water meter for a lot of the school campus and for firefighting. So therefore, they have to heat this building every year. And that's the only thing as far as to house a furnace to keep the water pipe freezing. So in May of 2022, the water main broke right outside the building. It flooded the building, and it caused, where that plywood is, there, believe me, there's a 6 foot by 4 foot hole. For some reason, I didn't take a picture of it, with the plywood down there. But there was a 4 foot by 6 foot hole in the foundation. And it looked repairable to me. The brick up on top stayed in place, didn't crack as a result. Good candidate for simple repair. Took me 4 days, drew the plan on the bottom right side. In this case, it's in an area where the historic preservation group had to approve the plan, even for patching this simple hole in the stone foundation. The historic preservation people meet every other month, and it was too late to meet with them for their upcoming meeting, so we scheduled it about 2.5 months later. They didn't want to react quickly and just approve this repair process. So there was a 2.5 month delay. July 26, 2022, we had the west day on record at 8.6 inches of rain at Lambert and reported 11 inches in this particular area of town. So we had more collapse of the stone foundation. We had the brick fall down from above. And now if you peer into the building, you'd see that the roof rafters are bearing on this little bit of brick that's left. The owner and I contacted several companies. We could find no one that would put a man inside to shore the building so that we could make repairs. That's a problem. So the engineer of record, who was me, declared the building structurally unstable, unsafe to enter for any reason, and then we had to change the permit from a repair permit to a demolition and try to tear down an 1840 building in a historic area. Historic preservation folks don't want to believe you, and they believe, yeah, I'm just telling stories because we really want to tear this building down. But we had the process of works to repair it. We really did want to repair it. We didn't want it down. So I wrote a condemnation letter. Various constituents, the owner, the city, and the historic rehab folks argued it out, but in the end, the city approved the demolition. And it's not that simple. You can't just go in and tear down a building because you want to. First, we had to do a hydraulic study on this city block because all the drainage was right towards this building, and we had to accommodate for the storm drainage. So that was performed. The overhead electric feeding part of the campus and another electric building nearby was directly overhead. We had to move the electric. We had to move the natural gas line that was right outside the building. We had to move the water main and meter out of the way so that we could demolish the building and no longer needed to maintain the meter. So all that added up another $100,000 project. It wasn't $20,000 repair, but $20,000 removal. And the building next to this was 3 feet away, so we couldn't just rip it out. We had to shore it up, allow it to be taken. So that's what it looks like today. That wall has to be replaced, the historic wall. Any questions? This one's more apparent. Can this building be saved? When I walked up to it, it looked like this. So this was a case of an old town, very poor roof, built up roof that just wasn't maintained over the years, and water got into the wall. It's just obvious from the condition of the brick and the mortar that was laying in the pile there. It just wasn't maintained. It was just a heap of debris. And now the same question comes about: how do you go about stabilizing this? Can you retain what's there? Is it worth repairing it all? Is it worth? Can you get in there to shore it? When you look at the joist ends that are projecting out, they're all roddy. So you'd have to somehow you'd have to shore this, endangering the people doing the shoring in order to peel back the roof, in order to peel back the rotted wood. In the end, you don't have anything that you're working with. So my recommendation was to determine that it's a total loss, and the insurance paid for it, and the owner reflected for that. It was just neglect, water getting in for years and years and years. And the left side, the odd thing about this is that the part of the brick building that remained standing was an attorney's office, and his library was in this right end. So he just stashed all his old books in there, but never went in there and never saw everything decaying around it. Well, it's interesting. The first floor remained in place, so no, didn't contribute. This is an interesting, what looked like a tuck pointer job. What we've got is an underground parking garage that serves 4 or 5 buildings, condominium buildings in this area. The roof of the building is waffle grid concrete, and there's 3 feet of dirt on top, so that there's walking paths and very pretty tree line paths between the buildings up above the garage. Owner contacted me originally, and they're fielding complaints about debris falling onto cars that are parked in the garage. So something's up. And as I walked through, I saw rusted rebar popping, becoming exposed as the concrete's popping off. So to me, this was a pretty serious matter that needed a thorough investigation. The HOA decided not to do that, but they did want to tuck point and repair this open garage. So I just knowing how the rest of the condition of the garage was behaving, we had a mason come in and remove portions of brick at the ends of there's a steel lintel there that looked pretty rusted, but I wanted to see how bad it was rusted behind that brick. So we had brick removed from 2 locations. There's the underside of the lintel. It looked pretty rusty. You can see the snow on the concrete pathway above. There's open joints everywhere in the concrete right above this arch. There was a concrete curb added around one of those columns above the archway, and it's just sucking water into the structure. And again, the HOA's resolution for a long time was to put up caution. So as we remove more and more brick, we can see that there's just nothing left of the arch. So the arch had to be replaced, brick had to be replaced, and we had to do something about waterproofing this concrete structure, which was just becoming a sponge. So here's photographs of the structure after the brick and the archway, the lintel had been removed. Surprisingly, the concrete is really in remarkable condition. but there were some rebar pops on the underside. The rebar was heavily rusted there right in the center, so we had that wire brush back down to steel. We had the concrete abraded and all the loose concrete chunks removed around it. While the steel arch was being fabricated, which happened to cost $3,000, by the way, these are the work steps that we're going through. We applied a bonding agent to the broken rebar with the Sika Architect 1000 EcoSim. And that allows the concrete repair mortar to adhere well to the concrete that's already there. So we use Sika Top 123 Plus polymer modified concrete mix as a structural repair. That stuff gets hard in minutes, so it has to be tooled and struck off exactly as you want it, no going back after it's hard, it cures. It has a hardness of something like 8,000 to 10,000 psi. So great product. This has to be worked with quickly. Then we wrap the exposed beam, concrete beam with carbon fiber, bolted on the new lintel. Use a Trumco waterproofing product to waterproof the face of the concrete and carbon fiber, replace the brick. Everything's nice. The problem is that the owner, as is typical on my plans that I do this time of year, the first thing is the call out for code, the codes that apply, 2015 International Building Code. And item number 2 was, under no circumstances should any of this work be performed in sub-freezing weather. So the building manager decided to ignore that, and the contractor was out there in February trying to pour concrete. So that required tenting, the cost of tenting itself, keeping all the materials wet or dry and warm enough to not freeze. So sometimes you get owners doing bad things. This is the Architect product, black surface, and the tenting below. And we have angry people in the meantime who can't park in the parking garage, which is 5 buildings worth of people searching for parking spaces on an already crowded street. And we've got an owner who didn't like the additional cost of having to modify the process to accommodate work in freezing weather. There's a picture of the Sika Top 40-pound bag. That's a 44-pound bag. And wood form that was used to form the Sika Top to match the lintel shape. There's a carbon fiber in place. Carbon fiber with a lintel bolted to it in place. Detail of the lintel. Waterproofing in place. And a final product except for final pointing of the brickwork.
When you repair the top,
I fielded calls a few times from this property owner. They probably have, I don't know how close it is to collapse, but they've got a bad situation. You see rebar, exposed rebar and concrete falling off of any concrete beams, especially waffle grid. You're in the danger zone. And then with 3 feet of soil on top, and the age of this building, you can't keep that concrete dry. It's going to continue to deteriorate until something worse happens someday. And this is one of my favorite cartoons. I skipped a little on the foundation, but no one will ever know it. Any questions?